Hello students, good morning one and all. In last class I discussed about PMI. Okay, in PMI chapter one question is very important. One question only they will ask, that is 5-mark question. Okay, so here nearly 20 problems is there. Among the 20 problems they will ask only one question. This chapter carries only 5 marks. Okay, sets chapter carries 8 marks, relations functions carries 11 marks, trigonometry chapter carries 17 marks. Okay, PMI chapter carries 5 marks. Okay, in this chapter only 5-mark question is very important. Okay, yes, yesterday I discussed 1 plus 2 plus 3 plus 1 plus n is equal to n into n plus 1 divided by 2. Okay, now second one short question is, that is prove that 1 square plus 2 square plus 3 square plus 4 square plus 1 plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6. Okay, that is 1 square plus 2 square plus 3 square plus 4 square plus 1 plus n square equals to n into n plus 1 into 2n plus 1 divided by 6. So that is the given statement. So the given statement can be represented as P of n. P of n equals to 1 square plus 2 square plus 3 square plus 1 plus n square equals to n into n plus 1 into 2n plus 1 divided by 6. Okay, so now I have to take for n is equal to 1. Now I have to check for n is equal to 1 and n is equal to k, and finally we have to prove that n is equal to k plus 1. Okay, for n is equal to 1, that is 1. Where is n is there? Here n square is there. That is 1 is equal to 1 into 1 plus 1 into 2 into 1 2 into 1 plus 1 divided by 6. 2 into 1, 2 ones are 2. That implies 1 is equal to 1 plus 1 is 2, 2 into 1 2, 2 plus 1 is 3 divided by 6, 6 cancel, therefore 1 is equal to 1. Okay, therefore P of 1 is true. P of 1 is true. Okay, next assume n is equal to k. The given statement can be represented as P of k. P of k equals to 1 square plus 2 square plus 3 square plus so on plus k square equals to k into k plus 1 into 2k plus 1 divided by 6. Okay, therefore P of k is also true. P of k is also true. And finally, P of 1 is true, P of k is also true. We shall prove that P of k plus 1 is true. Okay, we shall prove that P of k plus 1 is true. Okay, we have to prove that P of k plus 1 is true means I have to take LHS of P of k. That is, consider 1 square plus 2 square plus 3 square plus so on plus k square plus k is extension of k plus 1. That is k plus 1 whole square. Okay, I have to consider this LHS. This LHS should be written in the form of up to extension of k plus 1 whole square. Okay, now here 1 square plus 2 square plus 3 square plus 1 plus k square value is this much. That is k into k plus 1 into 2k plus 1 divided by 6 plus k plus 1 whole square. Okay, that is k into, I have to simplify, k into k plus 1 into 2k plus 1 plus 6 of k plus 1 whole square divided by 6. That is, here here k plus 1 is there, here also k plus 1 is there, k plus 1 is common, k plus 1 is common, here remaining is k into 2k plus 1 plus, okay, k into 2k plus 1 plus 6 into k plus 1 divided by 6, okay, that is k plus 1 into k into 2k square plus k into 1 k plus 6 into k 6k, okay, is k plus 1 into k into 2k is 2k square plus k into 1 is k plus 6 into k 6k, 6 into 1 plus 6 divided by 6, okay, that is k plus 1 into, that is 2k square plus 7k plus 6 divided by 6, and this can be written as k plus 1 as it is, and again 2k square plus 7k plus 6 you should factorize. 2 6 are 12, okay, 2 6 are 12, 12k square can be written as 3k plus 4k, okay, that is here that is 2k square as it is, 7k can be written as 4k plus 3k plus 6 divided by 6, that is k plus 1 into here in these two terms 2k is common, 2k into k plus 2, here in these two 3k is common, 3k into k plus 2 divided by 6, that is k plus 1 into that is k plus 2 into 3k 2k plus 3 divided by 6, okay, this is your answer, okay, see children, k plus 1 as it is, here this is one term, this is one term, k plus 2 again common, remain is 2k plus 3, okay, 2k plus 3 divided by 6, and this can be written as, okay, this can be written as that is k plus 1 as it is, k plus 1 as it is, k plus 2 can be written as k plus 1 plus 1, 2k plus 3 can be written as 2 into k plus 1 divided by 6, okay, see you will get the previous step only, 2 into k 2k, 2 into 1 2, 2 plus 1 is 3, 2k plus 3 only you will get previous step, okay, and again wherever n is there I put k plus 1, observe here n is there, k plus 1, here n is there, k plus 1, here 2 as it is, n is there, k plus 1 divided by 6, therefore here there is no space, I will tell orally, here p of k plus 1 is true by PMI, hence by PMI p of n is true for all natural numbers, okay. Observe once again, this is very important problem, that is prove that 1 square plus 2 square plus 3 square plus 4 square so on plus n square equals to n into n plus 1 into 2n plus 1 divided by 6. The given statement can be represented as p of n, okay, that is for n is equal to 1, so that so on 1 is equal to 1 into 1 plus 1 into 2 into 1 plus 1 divided by 6, 1 is equal to 1 plus 1 is 2, 2 plus 1 is 3, 2 3 is 6, 6 divided by 6, that is 1 is equal to 1, therefore p of 1 is true. Assume n is equal to k, p of k equals to 1 square plus 2 square plus 3 square plus so on plus k square equals to k into k plus 1 into 2k plus 1 divided by 6. P of k is also true, okay. We shall prove that p of k plus 1 is true. Consider P of 1 is true, P of k is true. Now I have to prove P of k plus 1 is true. Okay, consider here wherever n is there, replace n by k. Okay, that is 1 square plus 2 square plus 3 square plus so on plus k square. This k up to extension of k plus 1. Okay, now this value is there here. Substitute k into k plus 1 into 2k plus 1. Plus k plus 1 whole square divided by 6. Taking the LCM and simplifying, you will get 2k square plus 7k plus 6 divided by 6. Factorize this one, k plus 1. Here 2 6 are 12, 12k. That is 12k square. 12k square can be written as 4k into 3k. 4k plus 3k is 7k. Okay, 2k square, k plus 1 as it is, 2k square plus 4k plus 3k divided by 6. Okay, that is here 2k is common, here 3k is common. 2k is common, k plus 2 plus 3 into k plus 2 divided by 6. Okay, and again k plus 1 into k plus 2 into 2k plus 3 divided by 6. Therefore, P of k plus 1 is true for all natural numbers. P of n is true. Okay, this is solution of this problem. Next we will move on. Next, one more important derivation, that is prove that 1 cube plus 2 cube plus 3 cube plus so on plus n cube equals to n into n plus n into n plus 1 divided by 2 whole square. This is also very important derivation for 5 marks. 1 cube plus 2 cube plus 3 cube so on plus n cube equals to n into n plus 1 divided by 2 whole square. Okay, similarly, that is I have to write P of n equals to 1 cube plus 2 cube plus 3 cube plus so on plus n cube equals to n into n plus 1 divided by 2 whole square. For n is equal to 1, for n is similar for n is equal to 1, n is equal to k. These two steps are compulsory for all problems. Okay, same steps only for all problems. Okay, for n is equal to 1, that is P of n, that is 1 is equal to 1 plus 1 divided by 2 whole square. This one cancel, 1 is equal to 1. Therefore, P of 1 is true. Okay, next, P of k equals to 1 cube plus 2 cube plus 3 cube plus so on plus k cube equals to k into k plus 1 divided by 2 whole square. That is P of k is true. P of k is true. Okay, now we shall prove that P of k plus 1 is true. Okay, so when we have to prove that P of k plus 1 is true, we have to consider that is 1 cube plus 2 cube plus 3 cube plus so on plus k cube, and expansion is k plus 1 whole cube. Okay, that is 1 cube plus 2 cube plus 3 cube plus so on plus k cube, value is k into k plus 1 whole divided by 2 plus that is k square plus k plus 1 whole square divided by 4 plus k plus 1 whole cube. Okay, and this can be written as, okay, and when we take LCM, that is k square into k plus 1 whole square plus 4 into k plus 1 whole cube divided by 4. Here k plus 1 whole square is common. K plus 1 whole square is common. Remaining is k square plus 4 into k plus 1 divided by 4. K plus 1 whole square into k square plus 4k plus 4 divided by 4. That is k plus 1 whole square, and this can be written as k plus 2 whole square divided by 4. Therefore, k plus 1 whole square into k plus 1 whole square divided by 4. Therefore, P of k plus 1 is true. Hence, P of n is true for all natural numbers. Okay. For any problem, these two steps are compulsory. Okay, these two steps are compulsory. P of 1 is true, P of k is true. Okay, from here once again observe here, consider 1 cube plus 2 cube plus 3 cube plus 1 plus k cube plus k plus 1 whole cube. Substitute this value. Here k into k plus 1 divided by 2 whole square. This can be written as k square plus k square into k plus 1 whole square divided by 4 plus k plus 1 whole cube. Okay, taking LCM. Okay, and again in these two terms are k plus 1 whole square is common. K square plus 4 into k plus 1, and simplify, you will get k square plus 4k plus 4 divided by 4. This can be written as k plus 2 whole square. Okay, k plus 2 whole square divided by 4. K plus 1 whole square into k plus 1 plus 1 divided by 4 whole square. Okay, therefore P of k plus 1 is true. By PMI, P of n is true for all natural numbers. These two problems are very, very important. You have to practice 2 times and you have to send me through WhatsApp. Okay, in next class I will discuss remaining problems of PMI. Today I am concluding the class. Thank you, one and all.